Hello, students. We're continuing to talk about areas of quadrilaterals. What are some of the quadrilaterals? We've talked about some. We talked about squares, not triangles. We talked about rectangles. What are some of the other ones that we've come up with? Parallelograms. I don't think I spelled that right. Parallelograms. Kites. Those are my favorite. Kites. Rhombi. Rhombuses. Trapezoids. Can you think of any others? I feel like I'm missing something. Just a quadrilateral. Maybe you can find something I'm missing. So we're going to talk about today the area of kites, rhombi, and parallelograms. And I learned that you can say either rhombi or rhombuses. Both are allowed. This is a kite. It looks like a kite. I can take it, I can turn it this way, and it looks like I could go down to the Berkeley Marina and fly it. I enjoy going down there. Haven't been in a while though. So kites, you can look inside a kite and you can see that it's actually a pair of congruent triangles that are a reflection of each other and they share a common side. So when I look at this picture, I can see that there is a triangle QRS right here. Okay. And if a line QS is the line of reflection, you can see that QRS would map perfectly onto QPS. Okay, these sides are the same, these sides are the same, the side in the middle is the same. So a kite is actually made up of two reflecting congruent triangles that are attached in the middle. Some cool things happen because of that. So because this is the line of reflection and because these two triangles are congruent, this angle and this angle are congruent. On this side, this angle and this angle are congruent. That means that this line QS is bisecting, cutting in half these angles. It's kind of interesting. It also means that this big obtuse angle R is the same as angle P. I'm just marking up the things that are congruent, the corresponding parts of those congruent triangles. Something else that you might be able to see in this picture is that you actually have two isosceles triangles. So I can think about it, this little triangle is what kind of triangle? It has one side there and one side there. So this triangle is isosceles. This big one out here is also isosceles. So there's a lot of ways to slice and dice this kite. One thing that's true is that the angles, do you guys know what it's called when it goes from one vertex across to the other vertex in a quadrilateral? It starts with a D. It's called diagonal. So kites have a short diagonal and a long diagonal. The short diagonal and the long diagonal meet exactly at a 90-degree angle. So if I was trying to find the angles on here, this would be 90, 90, 90, 90. And then I could find this angle over here is going to be 35. And then I could figure out whatever's left over in the triangle. So these are kind of fun. Basically, kites are, you know, isosceles triangle problems and congruent triangle problems. Let's actually try to find the area of the kite. Well, the kite's not done yet. This is one of the two triangles of the kite. So I'm going to say this is my line of reflection, and I'm going to go 1, 2, 3, 4. So I need to go 1, 2, 3, 4. That's going to be another vertex on my kite. Okay, and then I'm going to finish drawing my kite here. Okay, that is now a kite. And I could use the distance formula. I could find all the sides. It looks to me like this one is the same as this one because it is. It's the same number of squares over and up. Okay, same thing here. These squares are the same. Now, what if I want to find the area? Well, there's a lot of cool ways to do that. I could find the area of this triangle and multiply it by 2. That's probably the most straightforward way to solve this problem. So I'm going to count. It's on graph paper. So I'm trying to find the area. I'm trying to find the number of squares that fit inside of here. I'm going to find the number of squares that fit inside this one and then multiply it by 2. Okay, so I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this diagonal here is 11 units. That's a teeny tiny u for units. Okay. So I'm just going to look at this original triangle we started with. Where's the height? Well, it's not this side and it's not this side. The height is not shown in the picture. The height of this triangle is actually right here. Remember, right angle. How long is that? I can just count it. 1, 2, 3, 4. So the height of that triangle is 4 units. That's a very ugly U. Okay. And then I could go from there. So I could do 11 times 4 divided by 2, because that would give me the area of this. And then I could multiply the whole thing by 2, and that would give me the area of the whole shape. So one way to do this problem is to say that the area of the kite equals 2 times the area of each triangle. Okay, and I just said that the area of the triangle is half the base times the height, and this is the base and the height of the triangle, not of the kite. And then you could go from there. Another way, this is my favorite area formula. I like the one for regular polygons. It's one of my favorite formulas. So the area of a kite is half diagonal 1 times diagonal 2. What the heck? Let's see what that looks like. Very cool formula. Here's how you would write it with math. I would write the area of a kite equals half, and then we would use d subscript 1, d subscript 2. So d1, d2 is usually how I would read this. The area of a kite is half diagonal 1 times diagonal 2. Okay, so where are the diagonals in the kite? Well, this diagonal, the long diagonal, is there. Where's the short diagonal? That's going to be through the kite from one vertex across to the other. So if this is 4, this is also 4. So what's the total diagonal 2, I'll call it? This diagonal is 8. So if I'm going to do this problem using the formula, I'm going to do the area of the kite is half, and I'm going to do 11 units is the long diagonal, and the short one is 8 units. That order doesn't matter because it's multiplication. I could have switched that just fine. There's nothing that says the long diagonal has to be the first one. Okay, and then you have the area of the kite. And I'm going to multiply these together. Half of 8 is 4. And 4 times 11 is 44. And units times units is units squared. And this is how your word could look. You have the formula, you substitute using parentheses, you include your units in the substitution, and then you write your final answer with your square units, because what's area? It's the number of squares that fit in something. Okay, I just want to show you one more thing on that, and that is if I take this triangle and I rotate it and I put it over here, do you see how this would fit perfectly there? Do you see if I take this chunk out and I spin it up over there, see how it works really nice? And I can do the same thing with this little triangle. I can spin it and make it fit right there. The cool thing about this is that if this part goes over here and this part goes over here, what shape is this? That's just a rectangle. Okay. And what's the bottom of the, we'll call it the base of the rectangle. Base of the rectangle is 4. What's the height of the rectangle? 11. So I could just do 4 times 11 and get 44. Okay, so those are some ways to think about the formula for area of a kite and where it came from. All right, let's apply it. So I'm going to look at this figure. First of all, I know this is 32 degrees just because it is. I know these are right angles. Okay, and I could use triangle sum theorem to figure out what that is. I would just do 90 minus 32. And that would tell me that. Okay, but I'm trying to find the area. Find the area. And I have some given information here, which I'll add on to my figure. I know from W to Y is 12. I'm gonna write it in the middle here. So I know that it's for the whole thing, not for part. Okay, and from X to Z, that's also a diagonal all the way through, is 14. 14 units. Yeah, you do have to be careful because you don't know if the 14 goes from here to here or if it's the whole thing. That's one reason why I had to write it separate and not include it in the markings. Okay, does it matter what the angles are? Not really. Could I find all the angles in here? Yes, I could. Maybe. Not sure if I could find those. Maybe I can. Okay, next is, what's next? Oh, I'll use the formula we just had, which is the area of a kite is half diagonal 1 times diagonal 2. Yeah, so the area of this kite is, oh, I could name it WXYZ is, there's a bug, is half diagonal 1, it doesn't matter which one, I'll do 12 units, times diagonal 2, which is 14 units. So the area of kite WXYZ is half of 12 is 6, and 6 times 14 is some big number. What is it? It's 84. So we have 84 units squared. I put that in a box. I have found the area of the kite. Good job, me. Okay, I think we're gonna let you try that one on your own. Notice that from R to T is 4 units. That means the diagonal is going to be not 4, but twice that. Because in a kite, the diagonal is cut in half. The short diagonal is bisected. So that's also 4 units. Okay. Next shape, a rhombus. What is a rhombus? A rhombus is a very special type of parallelogram with, what makes something a rhombus? 4 congruent sides. Okay. Is a square a rhombus? Does a square have 4 congruent sides? Bet it does. Okay, a square is a rhombus. The little kid name for rhombus is diamond. Okay, you can have really sort of long, skinny, whoa, that didn't work. Really long, skinny diamonds. Or you can have kind of short, fat diamond. The point for this is that all the sides have to have the same mark. Okay, and all the sides have to have the same mark. What about the diagonals of a rhombus? And we would name it with the 4 letters in the corner. A square is a rhombus, but not all rhombuses are squares. Let's look at the diagonals. The diagonals are kind of interesting. So I should probably do this on graph paper if I want to do it perfectly. But what's going on with those diagonals? Again, my picture's not very good, but you guys see what's that word where they cross just like that? Starts with a P really long. Same as the kites. Okay. The diagonals of a rhombus are also perpendicular. Not only that, so they are also created by you know, you could see lots of how many triangles are in a rhombus when the diagonals are drawn in? Well, we have the 4 little ones, and then we have these 2, and then we have these 2, right? So I see 4, 5, 6, 7, 8 different triangles. And what about all the little ones? All the little ones are all exactly the same size and shape. Okay. So we got 4 teeny tiny little right triangles. We have some isosceles triangles. So we have that angle and that angle are the same. That angle and that angle are the same. Oh my gosh, this angle and this angle are the same. So we have a bunch of cute little right triangles in here. And after we do our whole chapter on right triangles, then we can solve even more in rhombuses. I can give you one piece of information and you can solve pretty much the perimeter, the area, all the angles, everything. It's kind of crazy. Okay, so what's the area? How would you find the area of this rhombus? First of all 4 of these triangles are what? They're congruent, right? All right angles in here and all congruent triangles. This is the short side, short side. I just got confused. I'm tired. Yeah, there's 4 congruent triangles in there. You should believe me. Haha. And they're all little right triangles. All right, let's mark what we have. So again, it's telling us about the diagonals. So it says from B to D is 8. I'm going to put 4 units here and 4 units here because I think that'll be a little clearer. The total is 8. Okay, and from A to C is 12. So I'm going to put 6 here and 6 here. Yeah. I could find the area of one of the triangles and multiply it by 4. So the area of the rhombus is going to be 1 triangle times, then there's 4 of them. So 4 times the area of the little itty bitty right triangles that are in there. Okay, there are 1, 2, 3, 4 right triangles. I could choose one of them. I could find the area. It's the base is 6. Maybe I'll do this in this color. Ooh, pretty colors. Base is 6 and the height is 4. Okay. Area of a triangle is half the base times the height. So the area of this triangle is going to be half of 6 times 4. I think I'll do it this. Half the base of the triangle times the height of the triangle. So in this problem, it's going to be half of, that's a weird times symbol. Oh, maybe I should use parentheses. Half of 6, wow, that's getting worse. I'm going to keep it the weird time symbol. Half of 6 units times 4 units. Okay. And then you could type this 4 times 0.5 times 6 times 4. Okay, I see that this is going to simplify really interestingly. Okay, the other way we could do this problem is, well, it's kind of the same as the last one. Okay, I could take this triangle and put it over here, and I could take this triangle and put it over here, and turn this shape into a rectangle. Couldn't I? Do you see how that works? I can just kind of move the triangles around. Okay, then I'm going to have 12 times 4. Okay, would be my area of the rectangle. I'm going to use the formula. Okay, well, it's the same as the kite formula. It's the area of, oops, I don't want to do that. The area of a rhombus is also half diagonal 1 times diagonal 2. I like the diagonal formulas. Okay, so the area of rhombus ABCD is going to be half. One diagonal is 8 long, and the other diagonal is 12 long. And half of 8 is 4. 4 times 12 is 48. Units times units is units squared. Now let's see if I get the same answer here. So 4 times a half is 2. 2 times 6 is 12. 12 times 4 is also 48. However you do your work, you need to show your work. Okay, so I'm going to do area of rhombus, area of ABCD, keep it neat, keep it organized. Pay attention to details. Your Algebra 2 teacher will be very happy. And this one I'm going to let you work on and figure out. Let's talk about the last shape for today, which is a parallelogram. And a parallelogram is a quadrilateral with 2 pairs of parallel sides. So my question is this a parallelogram? I don't see any parallel side markings. How do we know? And what do I see? I see this triangle and this triangle. Okay, it's probably, it looks like if I took this one, I'll do it in blue. If I took this one and rotated it around this point right here, if I spin this around, could I get it to match up on the other one? I think so. And what's happening in the middle of this figure? What's happening in the middle? They're overlapping each other, right? So what have we been marking when we did that congruent triangle unit? We marked 3 little lines in the middle. So why are these 2 triangles congruent? Side, side, side. Or what I just said, you could rotate it around a point right here. And that one would map onto that one. Okay, so the 2 triangles are congruent because of side, side, side. This angle here is congruent to this angle here. Okay, this angle is between this 2 sides and this 3 sides mark. And then this angle down here is also in between this 2 side and 3 side mark. And those angles are congruent because the triangles are congruent. Corresponding parts of congruent triangles are congruent. Okay, now, what's a parallelogram? It has to have parallel sides, right? So, do you guys see what I'm about to do here? Whoa, that's really crooked. There's a line. There's a line. There's a line. And I think I'm going to redo this line. You guys see the figure that I just drew? What is it? Yeah, that's a transversal. And what are these? Maybe parallel lines. How do I know they're parallel? Because, wow. What are these called? Alternate interior angles. So what I've shown by saying these 2 triangles are congruent and their parts are congruent is that this angle and this angle are alternate interior. That means that BC is definitely parallel to the side AD. Yeah, I can do the same thing over again and show you with a different pair of parallel lines that AB is also parallel to DC. All right, that was fun. What about the diagonals in a parallelogram? What are those like? I don't know. All right, let's play with this one. So this is stating that it is a parallelogram. I could prove that it is because the angles inside don't have to add up to 180, they have to add up to 360. Okay, think about a square, 90, 90, 90, 90. How much is that? 360. So quadrilaterals, the inside angles add up to 360. If I subtracted that stuff out from 360, I would get this is 27. Okay, so another thing that's true about parallelograms is that their opposite angles match up with each other. And that makes sense because it's also, you know, two pairs of congruent triangles. So these angles have to match and those angles have to match. All right, let's see if we can find the area. That's what we're trying in this lesson. So from G to F is 6.9 units. I'm going to redraw that over here. Okay. And one really common mistake people are doing with parallelograms is they would figure out maybe this is 12 units. And then it's like, oh, it's like a rectangle. I can multiply these together. No, that's a trick question. The only reason we need that is if we had, we're trying to find perimeter. Okay, so that would be just there to trick you. What we have here is GE. And I'll use my red right here. So from G to E is 4 units. Okay, from G to E is 4 units. So how do I find the area of this parallelogram? The area of a parallelogram is base times height. Okay. How would I write that with the math? I would write the area. I tend to use a little parallelogram symbol. You could write it out. You could come up with your own notation as long as I know that you're talking about a parallelogram. And then it is base times height. So what's the base of this parallelogram? And height, we're always looking for that right angle. If I want height, I'm looking for a perpendicular height. So the area of this parallelogram is, oh, and I can name it parallelogram DEFG. DEFG is, base is 6.9 units and the height is 4 units. So the area of DEFG, parallelogram DEFG, is whatever that is. Now, why does that work? Look at this, you guys. See this triangle right here? Is it the same as this triangle right here? Yeah, it is. What if I just slid it? I just translated it straight over. Okay. Wouldn't it go to here? It would fill in perfectly, right? Can you see if I grab this triangle and I just straight translated it over to the right, some amount, it would fit in this spot right here. Okay, and then we would have our old friend, the rectangle. We have a 6.9 along the bottom and 4 along the side. Okay, that is why this works. So I'm going to do on the calculator 6.9 times 4. That is 27.6. Units times units is units squared. It better be. If I ask you for area and you don't tell me an answer with a squared in it, I will think that you don't understand anything about area, because area is the number of squares that cover a figure. Just check. Yep, that was it. Be good. Keep working. And keep learning.